Thanks for coming to this drug session. Today I'm going to take you on a small tour of soap services, but I will not tell you more about this because you're going to figure out later on what we will be talking about. And yeah, I'm really happy to be here at Jug Torino. I love jugs, I visit a lot of jugs, and it's perfect just to connect with the community, local communities as well. It's my first time in Italy. Yeah, I hope you're going to enjoy it. So, the boring part, my name is Tom, Bujok, spelled like this. I work for Center Active AG in Bern, in Switzerland. You can find me on Twitter at Tom Bujok, or you can visit my blog or my website like refisio.org. Small advert. The company that I work for has a product. It's a log analyzer. It can do like grep or tail or local and remote sources, and they have given me 3 licenses. So I will give it to 3 first people who ask a question. But there's one requirement: I have to be able to answer it. So if the question is too difficult, you will not get the license. So just be brave and ask a question. Okay, so yeah, why are we gonna actually talk about soap? It's not really like a hot topic anymore. It was introduced in 2005, and the specification, was widely adopted, between 2006 and 2010. Now it's not like a cloud or social or big data, or REST is probably too old, but NoSQL it's still like a buzzword. And and web services aren't the buzzword either. I mean, probably it's not that popular as it used to be. And the first reason is I hope we use soap daily, but being serious, it's like there's still a lot of endpoints. I mean, I worked in a bank, and in the biggest bank in Central Europe, and there's hundreds of endpoints, for example, that are really old, and that are RPC encoded, the oldest specification implementation, and you cannot simply touch them because they are there, they work. And yeah, that's it. And whether we like it or not, there's still a lot of endpoints. And yeah, I mean, in the next couple of years, people still will use SOAP. Maybe it's not like this that they will implement new endpoints, but doing IT projects, they are still present. And for example, big companies like telecommunication companies, they still prefer pretty often to have the WSDL, like the WSDL specification, as the contract between the suppliers and simply the IT departments that are working internally on projects. So that's the reason why we're gonna discuss it a bit. And as I said, today we are living in a world that's more like buzzword oriented. There's like this buzzword driven architecture term, and and it's like a mass movement. Let's say we are working on a project and we need a database, so it's not fancy anymore to take like MySQL, because if we say it, we are probably too old. We have to take like NoSQL because it's fancy, or we have to take Scalatra in Scala because it's AngularJS. It's really popular now, and I have nothing against these frameworks. I mean, they're perfect and they are driving the change in IT. But it's also noticeable that that somehow we stop thinking sometimes when we do the architectural decisions. I mean, do we really think before we choose the technology, or do we choose the technology because it's fancy, or because many people use it, or there's a lot of tutorials or JAG events related to this technology? And for sure, I was driving today from Bern to Torino, and you have to pass the range of Alps, and there's like a lot of tunnels that were built on the road. And do you think it was like this when they were building the tunnels, like from Torino to Switzerland? Do you think like the guys came there and had a couple of beers and said, yeah, this is the place where we're gonna build the tunnel, and the next day they started digging, and if something goes wrong, we're simply gonna change the place, or we're gonna choose like a different type of concrete? I mean, certainly, there are also failures in construction. It's maybe not a perfect example, but still, they do the evaluation, they plan, they somehow try to fit the best solutions to the project they are doing, and simply do it in the best possible way. And we want to do it today as well. So we will not, as SOAP is pretty old and it's not a fancy buzzword, but anyway, we don't want to evaluate it in such a way. We want to simply take it under the hood today and have a look at it and try to challenge it, whether it's still usable. Yeah, but before we do it, we have to we have to get one thing straight. And yeah, one question: how many of you, I already asked like before the meeting, but how many of you are using Java, like commercially? Okay. So my statement is Java developers are nuts, and don't get me wrong, I'm also doing Java like to make my living. Mostly like 90% of the code that I'm writing is Java. But I think, yeah, but I will give you an example. I'll tell you another story. This story is really cool. I mean, yeah, we're in Italy, so we want to buy a car, and you have a lot of fancy cars like Ferrari, let's say. I want to buy a Ferrari, so I go to a retailer and I say, I want to buy a new Ferrari. And the guy says, yeah, that's perfect, you want to buy a car, but I cannot sell you the car. I mean, it would be simply too easy. I mean, but I can sell you a factory where you can produce this car. And I say, yeah, but do I really need this factory? I mean, I just want to buy a car. I have money in my pocket. I mean, yeah, I want to just drive away. No, I'll give you the factory. It's the best practice. So I buy the factory. I go to the factory, and I say, yeah, okay, I bought you, and now I want my new Ferrari. And they're saying, yeah, it's you're on the way. I mean, you have the factory, but we cannot simply produce the car. We can sell you a builder, like a builder who will build the car for you. And I'm like, what? I mean, I just want to buy a car, and I have a factory, and I'll have a factory and a builder. I mean, okay, so give me the builder. So I take the builder, and with the builder I have to discuss a lot of stuff, and at the end of the day I get the Ferrari, and I'm so bored that I really forgot that I wanted to buy the Ferrari, and I really don't have even joy, driving the Ferrari, because it was so tiring. So it may seem abstract, but look at this XML parsing example. It's let's say we have this XML snippet. It's really straightforward and easy. And let's say we want to, in Java, we want to parse it and fetch the symbols, like get the name of the symbols that are in the XML. So the output would be like the Citibank and the UBS bank, like 2 strings simply. And we want to do it in Java. So here's our Java code. First, we take document builder factory, and we get a new instance. Okay, then from the document builder factory, we have to take a document builder. It's another instance. I don't know what to do with these instances because I simply want to parse my XML. Then I finally parse the XML, but I still have to normalize it. Nobody knows why, but there's this method, and if I don't invoke it, it will not work. Then I can finally, do the business logic. So I get the element by tag name, pretty long method name, but still, I get the stock. It was like one of the tags in the XML. And then I have to iterate over the nodes. And guess what? I cannot take the for each loop because it would also be too easy. I mean, they implemented it in such a way that the node list is like a custom list, and I have to use the C++ style node, like the loop, and get the nodes. And so on and so forth. And even though that I get a node, I have to check if it's a node, because it may be something else. And in the end, I have something like this. Which, when I look at this code, I'm scared of myself. I wrote it, and yeah, maybe it's not a perfect code, but it's basically the thing that you see if you type XML tutorial parsing a simple XML. And to show you the difference, what's really available now on the JVM, I'm going to show you like a Groovy snippet that can do perfectly the same thing. I simply take the XML slurper, I parse it, and then using the dot notation, I can simply put a name of the XML tag and print the elements. So in these 2 lines, if I were too eager, I could even do it in 1 line, but it would be probably too long to fit this slide. So yeah, I mean, I think it's really, in my opinion, there's a lot of code that can be simplified in Java because there's something more available now. I mean, maybe 10 years ago or 15 years ago when they were like designing the XML API, it was the best practice and it was the best way to do it. But I think, yeah, now it's much easier to do certain things, and we can simply just have a look around and see what's available. And it's not that difficult to, like with Maven or Gradle or any other fancy tool for building, you can add a Groovy source folder, and you can, like mix and match your classes in different languages, and even like reuse classes from different languages. But this is only an example, and yeah, so this is an example that also, in my opinion, apply to the web services stacks. And yeah, the reason why I'm here, because I think that I would like to challenge like the usage of SOAP in Java. And I think that there's a lot of improvement that may be applied to this world. Yeah, we have web services since 2004, and yeah, I think, and in my opinion, there was absolutely nothing changed from, let's say, yeah, okay, there are two specifications, so there was something changed because we got the annotations in Java 5 for web services. But anyway, the paradigm how we actually use web services has not changed since it was actually introduced. So. Yeah, so before we challenge the SOAP on the JVM, let's have a look what actually is available. We have a lot of frameworks, and they are perfect. I have nothing against these frameworks, and I've used probably most of them. I haven't used the WSO2. So we have Axis and Xfire that died, and then we have continuation of Axis and CXF that is a continuation of Xfire. We've got Spring WS, that's really cool. And we have two official implementations, from Oracle or Sun earlier, and the WSO2 is more exotic but still cool. So when we have to consume or provide a web service, the only topic that we are actually discussing is which provider we're going to use. I mean, and then people will start saying, yeah, I'm going to use CXF because it's cool, and I'm going to use Spring WS because it's it integrates with Spring pretty well, yeah, because it was implemented by Spring. But so, and we are not actually looking at what the real job is. I mean, what we have to do. We simply have to consume and provide a service, and we want to do it in the simplest way. And when we discuss, these frameworks, and when we think which one we're going to use, there's no much difference because most of them work in the same way. We either generate classes. If we use the contract first approach, we have the WSDL, and we generate code, and we can, code like a provider, a consumer, or we can have our business domain, like our classes in Java 5, and then we use annotations. And with these annotations, we can annotate our code, and it's going to be like a SOAP client or SOAP server in an easy way. But then we have to compile the code, and then, for example, if it's a simple standalone application, we don't have to deploy. But most of the time, it's I don't know, like a WAR or in Tomcat or like an EJB or something, and we have to deploy it and run it. So the whole process is really cumbersome. And the second discussion that we actually have to somehow conduct in our team is which approach we're going to use. I mentioned already the code first approach where we annotate, or the contract first. And there are wars, what's better, C++ or Java or Maven or Gradle. People will say one approach is better than the other. And this is a code first approach when we have our a business code. Let's say we have a person service, and that returns a person, where we when we give the UID, and we have the person as a domain class or simple domain class. It's really simple, and we simply add the annotations. I just removed a lot of them so that it's more visible. There will probably be a bit more, and that's our web service. And people can discuss, is it really a clean code or not? Because some will say that if we reuse our domain model in our web service and send it back to the clients, we are tightly coupled with the clients, because then I change something in the person class and my web service changes, my contract changes. So they introduced a data transfer object pattern or anti-pattern, where you take your person and you simply copy and paste it in your Eclipse or IntelliJ, and you put DTO at the end, and they are saying it's the best practice, because then whenever I send my object to the client, I'm sending the person DTO. And if I change this, I simply do the mapping from the person to the person DTO, meaning that I have my whole structure. Hello.
Sorry for being late.
No problem. So, meaning that I simply have my a structure of my classes double. I mean, I have two structures because I have the DTOs, and then I have to deal with the problem how I map the DTO to the normal objects. Code first, as the best practices. Okay. One license to win now. Who can spot the method name? I will count the second. 1, 2, 3, 4. Okay, 5 seconds. Who said it? Okay, you won one retrospective log analysis license. But exactly, I mean, is this really Java code? I mean, it's and believe me, there was more of them. I just removed them for the sake of this presentation because they do not fit the slide. I mean, if you code the code first approach, it may really, yeah, it's actually, there's a funny joke that was, I've heard it at DevOps this year at the conference in Belgium, and a guy said the mostly implemented project management methodology is called oops, because you simply code everything, you just do your project, and at the end you say oops, and because it doesn't work. So this is the thing actually. If you code your web services like this, you're gonna say oops at the end or somewhere in the middle, because it's like you simply misspell one of the schemas or something like this, and then the contract changes. So another example, we simply want to have like a client-server communication. So let's say we are doing an evaluation. We have to do a project, and and somebody gives us an endpoint and says, okay, in our project we have to invoke this endpoint. We will transfer some data and stuff. And here's your WSDL. I give you the WSDL. Here's the contract. We have to do something with this. And you say, okay, so let's emulate the communication. Let's do some, like proof of concept coding. Let's see how it works, and let's have a look at this WSDL simply. And so we want to do it in Java, and the amount of the number of files and the amount of code that will be generated is simply like overwhelming. I mean, so this is the resources and web app folder. So I simply took CXF, really cool framework, and I simply generated the code and the main runners and stuff like this to simply run it. So I ended up with like the WSDL. Okay, I got it, and the bindings, and the application context, and then the CXF XML, and then the web app and servlets, and web XML. I don't know why. I really don't need it for this case. I simply want to emulate the communication. I want to have like client and server running like in 5 or 10 minutes. But no, I still have to have Ant and Maven. I have to have the CXF CodeGen plugin to generate the code when I build and compile and stuff. I have to have the Builder Helper plugin because I have to attach the code to my source main Java so that it gets compiled, because it's not compiled to source. It's not generated to source main Java. It's generated to, I don't know, like to a third-party folder, like an external folder. So I have to attach it so it's compiled. Then I have to build a war if it's like a server, like a service server, like a server, not a client. And I have to have a Jetty plugin or Tomcat plugin or whatever.
He works for Jetty.
For Jetty, yeah, Jetty is cool. I use Jetty. So. Yeah, and that's basically the thing that I need to run this example. And I'm not necessarily saying this is bad. In some cases it's good, but it's simply too complex and too cumbersome. And for some use cases, it's simply like it's like the amount of stuff that you have to do is simply unacceptable. So
Overkill.
Sorry?
Overkill.
Yeah, it's an overkill, exactly. So. And the last thing, finishing the general part, the introduction part, is like the object-oriented paradigm. It's, I mean, we all use objects. I mean, objects are everywhere, and there's no other probably way. There's now the functional programming, and we are not. I don't want to say that object-oriented paradigm is bad. I just want to say that there are some cases when it has failed, and there are some cases when there's like it's much easier and it's much better to use something else. And there's like, if you want to have a look at this, there's a nice piece of reading by Richard P. Gabriel. He wrote like an essay or like an article titled "Objects Have Failed." And yeah, it's just, if you want to have a look, if you want to just go out of yourself and then have a look at something from a different perspective, it's sometimes cool to challenge the most popular or most widely accepted things, simply to see whether they fit the thing that we are actually doing. So So we can actually ask the question: Is this SOAP? Is this the way we use SOAP in Java or on the JVM really that clean? Is it really that neat? Is it really that fancy? Or can we really can we do something else? And as a like a counter statement, I like Groovy. I don't use it that much, but yeah, I use it sometimes. And this is like the example how you invoke Groovy REST service. Like and here I'm invoking the Twitter API. If you invoke this code, it will. This is my Twitter ID. It will simply println the last tweet that I have tweeted. So you can see I don't need any Maven plugins and CXF plugins. I don't have to generate any kind of fancy or cumbersome objects, and I simply put it into the Groovy code, not even having a class. I invoke it in a Groovy script and it works. So my goal actually is to yeah, and also I don't have any dependencies and stuff like this. It's really simple. I can do it in 1 minute. So my goal is actually to prove, or to try to prove, that it's possible to do something like this in Java or close to Java with SOAP, so that we don't have to repeat all the processes, all the things that I have just described, so that we can use SOAP in an easy and nice way in Java. And yeah, so you will have to check at the end of the session whether I fulfilled my requirement. So yeah, but there's like it's the road is really steep, because SOAP is not quite that easy as REST. I mean, with REST we have something, we don't have really a contract. I mean, the contract is there, but there's no description. It's more like invoke and see what's there. I mean, you take the REST service, you invoke it, you put some IDs, and you see, okay, I got the JSON or XML or whatever, and I see this is here and this is there. But somebody may change it, and there's no formal way of describing it. So that's not the case in WSDL and in SOAP, where we actually have WSDL, the web service description language. That's pretty complex, and with the green part as a like a abstract part and the implementation part. And yeah, I don't want to go into details with this. I mean, it's pretty straightforward, but it's like the most important thing is that we have operations. So we invoke operations. The get name was the operation that I have just shown, and when we invoke the operation, there are messages that are sent, like the request and response, and sometimes there's only request with no response, and the message is simply described by a type that's a simple type, or like a complex XSD or whatever in your WSDL. And then when we have it, port type we can ignore, and then we simply bind it to a specific protocol. So when we have the operations, we group them in port types, and we simply bind them, let's say, to SOAP. Or web services can also work fine with HTTP. So we simply do we define the binding, and then we define services, and we can use it. So the description language is pretty complex, and this is not the only problem. If it was the only problem, it would look really perfect. But we also have like different flavors or styles, whatever you want to call them, and yeah, and there are four official ones, like RPC encoded, RPC literal, and document and encoded or literal. And there's also one developed by Microsoft, which is like document literal wrap, that's trying to overcome some of the problems of the document literal. And it's described in a cool way on the IBM developer works portal. If you want to read something more about it, it really shows what the differences are. But I can just show you some of the XML examples of the SOAP envelopes, that fly between the server and the client. When you use this flavor, so with RPC encoded, you simply have the method name encoded, and there are some different type encodings that are really painful. With, let's say, RPC literal, you have the method name, but you don't have the encodings. With document literal, you don't have the method name, so you invoke a method, and you simply have the input parameters, and it's the either you specify the SOAP action, or you try to look at the parameters and try to match them to a method, and check whether these parameters with these names or these types match to a method, and blah blah blah. So I mean, it's not the topic, but it's a bit scary because like if we want to support it somehow in an easy way, I mean we have to overcome these problems, and And yeah, I mean, apart from other problems, I find it really difficult to work with the web services flavors, because it's like you never know what's generated there. I mean, especially with the type encodings. I mean, it's not that easy to simply take an XML and like with JAX-B that you have some objects and you simply marshal them and you have the XML and it's easy and you see that it looks the same as the object, but it's just a different notation, like an XML notation. And with this, it's like, you know, you see the SOAP envelope and you think, okay, that's the RPC encoded array that looks like, you know, that has 10 lines and then different type encoding. So it's complex. But there is hope because I want to show you the SOAP WS project. It's the project it's an open source project that I worked on. It's like a lightweight XML-oriented SOAP stack, which means that you can basically do fully functional SOAP communication, client-server stuff, and you don't need any stubs, you don't need any code generation, and it's simply like a lightweight thing, and it's based on Spring WS. And it's not only because I like Spring, and I think that this is really like a perfect implementation of web services, but also because when I was implementing this stack, it's like I didn't want to code any SOAP code, or like, you know, the communication and the layers of communication and stuff like this. I simply wanted to do something on the top of the existing SOAP frameworks, because I think they're really cool. But there's something missing in my opinion. So I wanted to put a layer on the top of the existing frameworks, and I found it really easy to do it with Spring WS, because it's really modular. And with Spring, for example, when you define one bean or override one bean in the context XML, it's easy to plug into a specific invocation phase of some, yeah, if you have like objects that invoke each other, they have dependency injected, and if you inject your dependency instead than the standard one from Spring WS, you simply plug in and you can handle the communication. So somehow hijack the session. So now I want to show you how SOAP WS tries to deal with these problems. First is the message generation. As I said, it's really complex, but let's have a look. I mean, so the first thing, whenever we have to generate a message, we need a WSDL, and we need to somehow parse the WSDL. So we have to know what's there in the WSDL, what kind of operation bindings and stuff we have there. So with SOAP WS, we take the WSDL parser and we simply parse the URL. It can be a local file or a HTTP file, doesn't matter. We parse it. Then, in order to build message, as we are discussing the message generation, we have to create an instance of an object called SOAP Builder. And this is like what I'm showing you here. It's like a really verbose way of defining it. It can be done really shorter in you know, like omitting some of the definitions and omitting some of the constructs, but it's like the verbose way to show you how it's really structured. And then we're gonna do the demo where I'm gonna use some of the shorter forms. And so we take the when we have the WSDL, we have to say which binding we are using. As I said, there may be many bindings in the WSDL, so we have to say, okay, this is our WSDL, this is our binding, and this is our operation. So operation can be found like using the operation finder. You can specify either the SOAP action or an operation name or like schema or whatever, and find the operation. And whenever we have the operation, we generate the message. So in these 4 lines, we parse the WSDL, we specify the binding, we specify the operation, and we build the input message. And we have the message built in an XML way. So in this input, there's this fully functional SOAP envelope, and it supports all of the flavors, like with RPC encoded and yeah, like document literal, the most important one nowadays. So it can be done in one line, as I said. You can see here that it's like a chain of operation of different builders and finders. And in one line, I can say WSDL parser, parse this WSDL, this is the binding, operation, SOAP action, find this, and build input message. So this is pretty sleek. And yeah, this is the interface. So you cannot only build like an input message, As I said, like in WSDL, you have this input and output messages, and you have also faults. Whenever you, let's say, invoke a message and there's an error, server error or something, you simply send a SOAP fault. Or you can build an empty message. For example, if there's only a request like fire and forget invocation. So this is the interface of SOAP Builder. Now I want to show you like how you can actually customize the generation of the message. Because let's say, okay, we have in the previous example we have built the message, we have the XML, but what was actually built there, we do not know. I mean, we know it's compliant with the WSDL, but there are some different like things that you can pass to the SOAP Builder, so that the messages that are generated are customized. Not in terms of the content, of the business content that you want to put there, but in terms of the WSDL constructs and just the things that we have in WSDL. So you can always build headers. Sometimes you want to omit headers, so you just simply set it to false. You can, for example, build optional fields. In WSDL, there's two kinds of fields. There are like the mandatory fields and the optional fields. And here you can say whether you want to build optional fields. Here you can generate, this is really cool because you can say, I want to generate example content. Let's say that I have an example that I'm going to show with the currency converter. So let's say we have a service that simply returns the exchange rate of two currencies. So if I build an input message and I set it to true, it will generate the sample values. Let's say, I don't know, between Swiss franc and euro it's 1.2. So it will generate like a sample float or double value according to the WSDL, so that I can right away use it, not paying attention to what I really put into the content. And there's more stuff like comments and excluded types and different weird things that are there in the WSDL that I don't want to concentrate on right now. But it's pretty extensive, and it's not like this that you simply generate it and then forget about it. You can do a lot of stuff with this. So in this simple way, we have the message generation done. Later on I'm going to show an example, so we'll just deep dive into it a bit more. So now, what I want to show you is the SOAP client. So let's say we have a message, or the message is really simple. Simply we generated it, or somebody has given it to us, and we want to invoke a service. So within this line, it's actually one-liner that's simply split with the dot notation. We can create a SOAP client. We can specify the endpoint URL. We can specify a lot of stuff like basic authentication or connection timeouts or stuff like this. And we simply build it. And then we can simply post a message specifying the SOAP action or not, and simply giving the message. And on the output, we're going to get the response from the service. So within this line, if we have the message that we have created in the previous example, we invoke the web service within, let's say, 2 lines of code. And there's much more, like we can specify proxies, or we can specify SSL and trust store, key stores, and stuff like this. So yeah, there's more builder options that are the most common ones that I have shown here. So it's pretty easy, and yeah, I have just shown how to do the message transmission. And yeah, the last part, before we go to the demo, because in the demo I want to show you like a fully functional client-server example, when we have the client and the server and the WSDL, and there's really like real communication between them. So we simply have to build the server as well. And the server, it's also like a similar builder interface where we specify the port. We can specify how many threads we'll be serving and blah blah blah. There's actually Jetty underneath, so it starts a Jetty server, and yeah, we simply start and stop the server, and that's it. So there's more as well here. I mean, timeouts and HTTPS and key stores and stuff like this. So yeah, more options, and some more are coming in as well. So, but when we start the server, we simply said we have a port and we start the server, but the Jetty will be there, but there will be no real business service. I mean, nothing really responding to our requests. And that's the last part that we have to do. We have to build like a responder, and responders are simply like objects that react whenever there's a message coming into a specific like context path. Whenever we have, let's say, like an application server, we have context path with service A, service B, service C, with the slash, and it maybe like have more degrees, service A, and then whatever, like different kind of addresses. And within the server that we have built in the previous slide, we simply register responder under a context path, saying that under context path Torino, we have this responder with this WSDL. And the responders may be, of course, registered or unregistered. And the beauty of it is that it can be done in runtime. So I don't have to start and stop the server. I don't even have to restart the SOAP server, like the object. I simply do it in runtime. So I simply take the responder and register it. And the interface is like really simple. There's an object called SOAP message, and the responder, we can implement it ourselves, simply saying, okay, this is my responder, and whenever I get a request, I can do blah, blah, blah. This is pretty simple, and it may look like useful, but it's not, because, you know, it's like we don't know what's there. I mean, whether the message is validated, whether the message is compliant with our schema, or what operation am I actually invoking. That's the reason why there's like an abstract responder implemented that actually implements the request responder interface that may be used like really in generic cases, but in most of the cases, the abstract responder is the way to go, as it really does all the hard work for you to check validate the input and output, and to check what operation is really invoked. So that whenever I build, like whenever we have seen in the message generation example, that in order to build a message, I need to know like what operation I'm actually invoking, for what operation I want to build the message. So the responder can give it to me because it tells me what was the message on the input and which operation is being invoked. So then we are safe, because what I can do, in the responder, I can say, builder, build me output message for this operation. Then I can tweak the response, putting some values or whatever, and I simply return the message, so the output. So in this way, I simply handle the invocation of a service. And that's actually the way how the apps there's something called autoresponder, and an autoresponder is simply like an automatic responder that whenever I have a WSDL, I can say autoresponder under path X, and whenever I invoke the service under path X, it will simply generate automatic output, giving some sample values, but the values that are compliant with with the schema. Like, I don't know if you have played with SOAP UI. It's like a tool for doing some web services, like, I don't know, tests or invoking or even generating servers. It's the same thing. You simply say this is my service and simply provide some kind of a stub of the service that will provide messages to the clients. Okay, I mean, this is how SOAP UI looks like, and now I'm going to go to the demo part, and I will show you how it's really working practically. If the Murphy's law is not working, it's going to work. If not, I'm sorry, but we're going to see. Okie dokie, so now we have to bridge the screens, and we have to record. Yeah, we have to ignore this update, and we have to turn on mirroring. So this is IntelliJ IDEA, and we're gonna do some quick time player recording. Not this one, not this one. We're gonna screen record. Yes, we're gonna this screen. Okay. So in this example, I would like to show you some server to client communication. So we're gonna have a WSDL. It's a sample WSDL. I have the WSDL already here. I can show you the WSDL. It's like a currency converter that I was mentioning. It's pretty complex, but the most important thing is that there's an operation called conversion rate in the binding called currency converter SOAP. And this method we'll simply try to provide. So we'll take the WSDL and we'll provide like a server that will provide this method. And then we'll try to invoke this server using the client so that we see the results. And then we'll try to do some more groovy magic on the top of it. So basically the code, it will be 90% Java code. One snippet will be groovy. but this is like a groovy script, so that I don't have to have a class and main method and stuff like this. It's easier just to follow, and for you as well, and for me to write it. So first we can generate some imports so that we don't have to deal with them anymore. And since it's a groovy script, we'll simply provide like exit 0 at the end, so that it's not IntelliJ is not complaining, and we're gonna check whether it works. Torino, hello world, and let's see if it works. Okay, here's the output, and it returns 0. So now we can start our coding. So the first thing that I have here is like I have some live templates, so that I don't have to type everything, and you don't have to watch my poor typing. But some of the code is already pre-generated. So here's our WSDL, and we simply need like a URL of this file. So we use like a resource util. It's also implemented in SOAP WS, like a utility class that can load resources like in Spring. There's similar one in Spring, but to do it you don't need Spring, and it works like within container and like in standalone mode as well. And what we need, as I said at the beginning, we need like a WSDL parser. So we parse the WSDL simply. We say WSDL parser, parse our URL, and there's parse the WSDL that's under this URL. And what it's going to do is simply it will download the WSDL if it's a local file, no matter whether it's like an HTTP file as well. And it will simply parse it, and we can then play with it. And in order to build the SOAP builder, we need to specify which binding we're going to use. And normally when you work on such stuff, you know which binding you are using, because it's your WSDL, or you got the WSDL, you had a look at this. But now, for hacking around, I have a cool method called print bindings, so that we can actually see what kind of bindings we have in the WSDL, not looking into the WSDL. It will already like pre-format with the with the schema and everything, so that we can use it in SOAP WS. So SOAP WS supports for now SOAP 1.1 and SOAP 1.2. HTTP is not supported, but it's on the way. But we're going to use the currency converter SOAP binding. So we're going to use the SOAP protocol, which is the most natural way to do it. So we're going to use the SOAP builder, and now we're going to simply say parser binding, and we're going to specify the binding. And the resolution is not that high, so we're simply split it, and we're gonna say builder, which means that from this parser we're saying we need this binding, and simply give us the SOAP builder so that we can build messages. And within this builder we can use like operation finder. So we can, for example, say operation, and then we can specify whether it's an input name or output name or SOAP action. We can simply try to find our operation. I'm going to use like a conversion rate name, because I have shown you that this is like this is the name of the operation, and in this way we're gonna get the operation, and what we can do with it, we can find it. It's a finder, and then we can do build input message, which will build our input message, and I'm gonna assign it to a variable called request. Let's call it string. And I can do more stuff. I can do I can do, for example, generate an empty fold or output message, and every of these messages is overloaded, so I can specify the SOAP context as well. As I have shown you, there's like give more details to the builder, what kind of message and how it's going to be generated. But for now, we're going to go with the defaults. They're pretty alright, and we're going to have the request generated for us, and we're going to println the request so that we can see how it actually looks like. So as you can see, this is like a full like SOAP envelope that's compliant with the schema, that's compliant with the WSDL, and yeah, and that's everything that we need to generate to invoke this service. But as I said, it's using some defaults, so the currencies. that are, this is the example content settings. I mean the settings. So the content of the request, the business content, is generated for us, so that we don't have to put it for now. I mean, for now it's not really that important. So we're gonna try to tweak it later on. As you can see, it's compliant with the WSDL. So on the beginning of the WSDL, there's a list of currencies that the service supports. So you cannot simply put any currency. There's a list of currencies, and they have published it, so it's pretty cool. And this SOAP builder, it simply tries to comply with these rules. It will not generate like a random string like XXX or whatever. It will simply take one of the options, and it has done it like as you can see here, like 2 values from the list. If I try to look at it's here, and the second one is probably here as well. If I find it somewhere here, yeah, it's here. So it's compliant. And now when we have the request, we will not print it. We want to have a server that will simply provide us with this service. So we're gonna do some server coding. And this is our server. We are using the builder. We are saying that under the port 9090 we want our server, and that's it. That's everything what we have to do. We simply say server start, and the server will be there. And as I said, it's only a server, it's a jetty, but we have to say what kind of operation under which context path we want to provide. So we need like a responder, and this is the autoresponder that I have described. It simply generates sample messages on the output, so whenever an operation is invoked, it simply takes the operation, checks whether it's compliant with the schema, whether the operation that we are invoking is there in the WSDL, and if it's there, it finds it in the WSDL, and it generates sample output, and simply sends it to the client. And here we are saying that under the context path service, we are generating this, we are registering this responder. So whenever a client invokes something under the context path service, this autoresponder will be there. And the last thing that we need to do now is like we need a SOAP client, and the SOAP client is pretty straightforward as well. Here's the code for the SOAP client. It's like we simply specify the address, which is in our case like the 9090 on localhost under the context path service, and that's it. And the last thing, we simply have to say client post, send the message, the request message, and we simply are gonna assign the response to a variable so that we can print line the response. And yeah, and I hope it's gonna work. Okay, so here's the output. The request that I have shown before was sent to the server, and the server that we have just registered provided us like with a response, and the response is like a sample float, which is like the currency conversion rate between the 2 currencies that we have given in the input. But this is pretty cool. But and this is all Java. But right now, as I have said, okay, we are still using objects here, and you can say whenever I generate my stubs, I have like full control over the request, because I can invoke method set from currency, set to currency, and I can just play with the request. And I don't. And here I have like a sampled request, so I have no way of changing the request or playing with the response or stuff like this. It's like a string. So now I would like to show like some more groovy tricks. It's pretty easy, and it's like gives you the full fluency of playing with the XML messages. I don't know if any of you has ever used Groovy with XML together. Okay, yeah, so it's cool. So the thing that we need is called like an XML slurper, and it will simply take our XML, and it will enable us to simply perform some modifications of the XML in such a way that it's not like in the Java code that I have shown like at the beginning, but it's like more easy way. So I have a live template for this as well. we need like a slurper, and we need like a method called pretty print. It's not really that important. I will put it at the end because it's not really that important. So this is gonna be our part. So we have the request. We'll comment out the response because it's not that important for now. Simply the request message. So how it works right now is that we generate the sample request message. And the sample request message contains the sample parameters, and we want to change it. In Italy you have euro, so let's say we want to change the conversion rate between euro and Swiss franc where I live. So we will try to adjust the message in such a way that we check the currency converter. So what we're going to do in Groovy, we can simply take the slurper that parsed our text as our request in this method, and we can take slurper, and now what's really cool, we can navigate in the XML simply structure using the tag names. So I can say slurper body, then I can say conversion rate, and then I can say from currency, and I can say euro, and then I can copy this line and put Swiss franc and change the from currency to currency. Then I'm going to use like a pretty XML method that will simply pretty print the output, because slurper does not return the new lines, so it will be everything in one line. And what I'm going to do now is I'm going to printlen the request one more time, so that we can see that the message has actually changed. So I'll run the example, and if it works, we're going to see two messages exactly. So the first message is the sample message with the random values, and as we can see, the second message is here, and the structure of the document, body, conversion rate from currency has been changed, and we have euro and Swiss franc. So within these 4 lines you can actually play with an XML document and change the tags, and it's not really cumbersome. I don't need like builders and factories and stuff like this. But it's groovy. You can also implement it in Java in a, let's say, not that short way, but also like a bit shorter than the standard one. But apart from that, it's not really a part of SoapWS. All the other code that's here is Java. It can work 100% in Java, and it's not using any groovy tricks. Okie dokie. So that's the demo. I don't know if you have some questions to the demo, or okay, cool. We can go back to the presentation. You have a question? Yeah?
Have you considered the overhead of building a string with the request, then passing it, and then rebuilding it again?
You mean like the
you
overhead of the slurper of the modification, or?
Yes, you first build a string, then you pass it. And
then yeah. I mean, yeah, of course. I mean, I didn't do it like extensively, but it's it all depends on the underlying XML library that you're going to use. I mean, because the slurper, it's also like configurable, but it's really quick, and it will not use the DOM model. I mean, it will not read the whole message and then navigate. It can simply, you know, go through the message and only change the things that you are, you know, addressing.
That's so the only option you have to pass the string.
Yeah, I mean that's I'm also not really sure how exactly XML slurper was really developed. I mean how it's implemented. So, but I saw some you know, like comparisons on the internet, and there was like an object called XML, not XML slurper, but I think XML builder in Groovy, and it was much smaller, and it used like much more memory. So they have optimized it. Like there was a guy who implemented this XML slurper, and it was like much less memory consuming.
I thought more about generating first the object and not the sample one without generating random values.
Aha. Okay, you mean so already generating the.
Generate random values, then pass it, and then.
Yeah, then parse it. Yeah, okay. I mean, yeah, that's a nice point. That would maybe that would work even better, because then you, let's say, you could provide these parameters to the SOAP builder, so that it already builds the message with. There is something called multi-values, so that you can specify like custom values for custom XML like WSDL simply parameters. and you can use it with the builder, but yeah, it's a bit more complex. And you know, it's like what I want to say. I mean, this SOAP WS, it's not also like a Swiss Army knife for solving all kind of problems. I mean, if you have like a totally big, you know, like a WSDL and with a request for, I don't know, 10,000 lines, then probably it's more easy to use like an object and play with objects. But let's say there are also like some cases where you simply want to invoke like a like very straightforward service, and or even whenever, you know, if the request is 10 kilobytes, you will not see this overhead, because you know you are not invoking probably 10 millions of operations every second. Yeah.
I've seen WSDLs of 3 or 4 megabytes.
Yeah, exactly. Then in this case, it's probably, it may be easier if you see like performance like deterioration. Then it may be easier to use like a standard model. I mean, it's not always like this that it will be better in all the cases. It's simply like, you know, you have to check and evaluate the thing that I was saying. If it works better for you, use this. If the standard model works better for you, then use the standard model. But regarding the performance, yeah, I haven't seen any really like complaints about this. Not even in SOAP WS, but I mean,
well, most of the time it's I/O.
Yeah,
time.
yeah, exactly.
Acceptable.
Exactly. Okay. Some other questions? No. Okay. So we have to now turn off the mirroring. And let's come back to our presentation. Okay, we have some more slides, the last part. And we are running out of time. I don't know, we have to leave like sharp 8, the building, or?
8:30. Half past 8.
Ah, okay, no, so now it's probably like 10 minutes. Okay, so we have finished, sorry? It's probably 10 minutes more. Yeah, it's not 1 hour. So the last part is the web services versioning, actually, because this is the whole idea why actually this library was created. We had a business need, and this library is actually used commercially in 1 or 2 projects. It's not really like it's on GitHub, and it's like Apache version 2 license, so you can do anything with this. But the version is 1.0 snapshot. It's going to be very soon 1.0 release, and it's tested to some extent. Like the test coverage, like using the acceptance test, not like JUnit tests, but really acceptance business test is like something around 70%, and everything is public. I can show you at the end of the presentation. But the real business case was that actually, you know, if I have one service and the service never changes, and I simply invoke it, it's not really that bad for me to have like to generate the stubs and play with the stubs. And I still have the stubs. I'm used to working like, you know, with Java code, so I can simply work with the objects. But the problems begins when I have to version my services. I mean, this is the simplest case. I have a client, business logic, and the stubs invoking some service, and I have the business logic and stubs and the WSDL. So right now everything is perfect. But if I want to do something like this, where I have 2 versions of the service, and I want to invoke one version, and in some cases, and the second version in some other cases. And I'm like, and what I want to say now is we don't have any ESBs or service providers or, you know, like custom mediators. We are simply coding. Let's say this is like we are a standalone application or like a web application where we invoke, I don't know, some service to register clients or get, you know, like last, you know, like purchases of the clients or whatever. So this is like a simple application. We are within a, we have a jetty guy, so we are in a war in a jetty, and we work with our application. And what we have to do now, in order to implement this case, we have to do some trickery, because it's not that easy to take one WSDL in 2 versions and generate the code and put it into one application. Because the problem is that, you know, if you change the whole WSDL completely and you have different object names and stuff like this, this is not that bad. But normally, if something changes in the WSDL, is it like a method name or object or some input parameters, meaning that 90% of the code that will generate in both cases is the same. So some, or even the object names are the same, but simply a parameter was added to the class. And it means that in Java, we are not in OSGI, so we cannot have like 2 classes in the same package with the same name in our source code. First, it will not compile, and second, if we have it in runtime, the first class, it happens sometimes you have, let's say, 2 XML providers on your class path. Simply the first class that's closer to the class loader will be loaded, and the second one will be forgotten. So we cannot solve it that easy, and it's really easy to break the compatibility of your WSDL. I mean, I don't want to go into details right now because it's not that urgent. But I mean, for example, if you, let's say, add a response parameter, one additional response parameter. So let's say I have a service, I invoke a service, I get a response, and if I get like an additional field that I don't know because it's not in my version of the WSDL, it's already breaking the compatibility. So, and sometimes it's not only about the input names or stuff like this. It's only about the schemas, where somebody changes some schema because we are relying on some other contracts, and the schema is changing, so we are changing the schema name, and it's incompatible, so we have to have a second service, simply second client for this service, because it's our code, our stub code will not handle it. It won't be able to handle this service. So yeah, if you look web service versioning in Google, it will already sell you like hundreds of consultants, and with with layers of indirections, and like service buses and portal servers, or IBM UDDI, although it's like it was shut down in 2006, but it's still online. So, and you will have a cool WebSphere server to solve all your problems, and this is their model, how they do it, whatever, let's forget it. And so this is ridiculous what's there. I mean, for our case, there are also like some some best practices on the web, and it's not and our case is simply we want to be able to consume or provide 2 versions of services within one code base. We have one code base, and we want to be able to do it. And we're gonna have a look at these examples using the level of lameness scale. It's my scale, so if you want to use it, you have to all rights registered. So you have to write to me, and I will sell you a license. But yeah, and it's not really, it's not about laughing at these guys who invented these patterns, because the scope that they had was limited. They were trying to solve the problem, but not really having full like range or variety of possibilities. So the first thing is that they say do not do versioning, force clients to migrate, and yeah, it's really cool. I mean, because if you are able to do it, you are cool, and you don't have to play with the versioning, and you go home happy, and but that's that's low 5. Yeah, by the way, 5 is like the maximum. So because in normal business it's almost impossible to achieve it. So for example, we had like a case where like the business process was running 6 months, because it was like a vindication. So they were checking like credit liability of a person who took a loan, and it's like every month they check salary, they check whether they pay the bills and stuff. So the process takes 6 months, and they spawn like 100 every day, and for example, and they change something every second week in the service. So every second week the process engine had to invoke like a different service. So they had like 20 versions of the same service, let's say in 6 months. So in this case, it was absolutely impossible, to scale it in a normal way. So yeah, we couldn't also force them to migrate. So yeah, there's a second cool idea. When you generate your code, simply create a second package and copy all the classes to this different package. It will work. It will compile. That's like high 5. But then, if your code is working on your business logic, let's say person and credit liability object, it will not recognize the second object from the package. So either you do some translation between these 2 structures, or you copy and paste your business logic as well, and you have everything in 2 packages, simply meaning you have 2 applications in one, in different package structures. So yeah, okay, I just put 4. It's not that bad, but it will work at least. But yeah, the third idea is different artifacts. So yeah, it's more clean because we don't have everything like in one package or 2 different packages, but we have 2 applications, and we our conscience is clean because it's in 2 different SVN branches, or 2 different projects. So it doesn't matter that the application is 99%. But when we run the sonar on it, it's like no application because it doesn't know about the second project. But when we change something, you have to remember to change in both places. So yeah, we have to, you know, be optimistic, free llamas. And yeah, this is like probably the coolest idea when our, you know, when we do not have any, you know, like sophisticated mechanism. This is like a mediator pattern, and this is pretty cool because in the previous example, when we have like different artifacts, if we have like 5 versions of one service, we would have to have 5 artifacts. And let's say we are consuming 2 services. In our case, we're consuming around 10, and the different versions of any of them could, like the version could change. So you can multiply 5, let's say 5 services multiplied by 2 versions is already 20. 2, it's 10, but then you have 4 additional, and it's already like 40. So it does not scale. I mean, if you have two versions, it would probably scale, but if you have 40, it will not work. So this is really cool because at least so it works like this, that whenever I have 2 versions, I have a mediator. So for my client that's invoking it, it can either invoke the old version directly, or if something changes, it invokes the mediator, so it mediates for him. So for the client, you don't see the change. It's not always possible because sometimes the client has to know that they have to send, let's say, additional parameter. But if it's only about schemas and some, like different small changes, it will work. And this is not that bad because, like, for example, if I want to add another service, I simply change the mediator. So I don't have like, number of artifacts like growing exponentially when you look at the number of service and the number of combinations that you can have, like different versions. So this is not that bad. It's mediation by hand, and this is basically what ESBs are doing for you if you're in a more like enterprise environment. So yeah, this is only one lane because, like, looking at the at the mechanism possibilities that we had, solving it like this, it's probably it's not the root of all evil, but it's not perfect either. Yeah, and to sum up, I would like to show you how you can do versioning with SoapWS. Because you don't have any stubs in SoapWS, you don't have the runtime problem. I mean, the only thing that you have to do is you have to handle the communication yourself. I mean, the message generation and stuff like this. So with how it works in SoapWS now, it's like we have business logic. So we have the Soap builder, and then we have the Soap server. Soap builder is building the messages. They may be empty or with sample context. And this is the area that you can where you can hook in and play with it. So whenever you are providing a service, you can, for example, have 2 different builders, and that will use 2 different supplementation methods. So it's actually unlimited. And for example, if you have, let's say, this mediation, like this implementation that you have this conversion rate message, and you put like the currencies, you can store it. Sorry, this is like supplemented. Wait a second. Yeah, so I want to show you code now. So whenever you have the supplementation done in XML, you do it in, let's say, in Groovy. You can do it in the Groovy Slarper, as I have shown in the example earlier. And with this supplementation, you can achieve the result of transforming the message. And it may be, for example, in this case, stored in a DB on a file as a Groovy script. So for example, whenever I want to invoke the service, I check the version which is invoked, and then I simply invoke the different supplementation mechanism. It may be either a file or I don't know, a DB, or you can even store it. You can store it in different places. But the idea is simply that you take different mechanisms that supplement your message according to the version of the service. So you have one server and one client, and simply different supplementation rules, which means you can hook in this stuff on runtime. So you don't have to restart and recompile your service. You simply, whenever you add a service, you can put like a Groovy script to your DB that will simply instrument the message, and it will work in runtime. So this is basically the idea. I don't know if you have any questions to this idea.
Yeah. So if you go back on slide.
Yeah.
So here, if I have to change the method name from currency to just from, then I can do this change using this Groovy script.
Yeah, I mean, because this, there are different possibilities, but I mean, you can store this whole code, let's say either the Slarper or even this code. You can store it in a DB as a Groovy script. And here you can say Groovy engine invoke script number 1, and the script is in your DB, let's say in the table supplementation rules, and you simply do a select. And if you have version 2 of the service, you simply take different supplementation rules or different parameters. But yeah, you can achieve, for example, the same thing with like XSLT, which is kind of complex as well, but it's basically the same idea. Then you can have XSLT files or XSLT content in DB.
And how do you know the version of the client is using? Because it invokes the same host and port, right?
So
it's in the message.
Yeah, one thing is it may be in the message, depending on what kind of versioning you are using. But I mean, the other thing is that I was showing here. I skipped too quickly through the slide. I mean, it may be, you may have different kind of strategies as well in this case. I mean, for sure it's not a mechanism to, let's say, version hundreds of services. It also may be confusing. And, if you want to have like 100, Groovy script in DB, it's also like a bit confusing. But if you say, let's say, have your application and you invoke 5 versions of one service or 4 versions of one service, then it's cool. Because if something changes, you do not recompile, redeploy your application. You simply do it in runtime. And one possibility is that you have only one builder, and if the change is small, you simply change the supplementation method here, implementing 2 supplementation rules. But if you say, let's say you have like really big major version changes, you can build your application in such a way that you have separate builders, and they listen on separate context paths. So you will say this major version A, context path A, and this version B, like context path B. So that you also don't have to do everything in this Groovy script, like a trickery, because it also may be like even checking the version may be sometimes not that easy.
Yeah, but you have to change the client in this case, because you have to change the URI.
Yeah, in this case, exactly. Yeah, but it can also, like, you can say, this is the versioning shown from the server perspective, but you can do the same thing on the client as well. I mean, using the SOAP client, this is like, just the other direction. That, let's say you have your application. The common case, the simplest case would be, for example, that you have a login mechanism to your, let's say, to your domain, and there are different kind of users. And if the user has a property X set, you log in this service. And if, let's say, the user has the property Y, you log into a second version because it's like a priority client or whatever. And this priority client version has changed because they have some extra features. And in this case, let's say you have only 2 or 3 versions in an application. And if you have like a normal, like JEE application, then whenever something changes, you simply play with the code, and it's not that easy to do. And with this mechanism, it has its drawbacks, but at least everything is happening in runtime. And at least if I want to change something, I don't have like the growth of my code base. It's just like I'm changing only the snippet that's really related to the change, the version change. I can even reuse the Groovy scripts, let's say, or import stuff. It's simply code. It's Java or Groovy, so it's much easier to do it than in the stub generation. Any other questions? Not really. Okay, so okay, we have to finish. There are some last slides now. Other stuff. One really cool thing is that right now I have integrated SOAP WS with JUnit, and I'm going to do like the Spock, the Groovy framework as well, the support for Spock. And this is really cool because, for example, how difficult it is if I want to invoke a service in my application. Let's say we are coding a JEE application, and and there is a server who is supposed to serve like some web service, but it's offline or we do not have access to it. And because of that, our application cannot, properly work. We have to stub it somehow, or we have to, do different tricks in order to make it working. And And the same relates to the tests. If I want to test my business logic and I have different environments, I cannot always invoke a server like in my tests, like a web service in my tests, because then I'm not really, sometimes it's not working, but because of many environments, I don't simply have them. So within this simple annotation, add server, I can say that under this URL, this binding and this port, expose a web server for the time being, for the lifespan of the test. For the lifespan of the test, and then I simply code my client, I invoke my business logic, and the service is there. It will do the auto-responding thing, which means it will reply with anything. And if I want to customize it, I can still do it. It's out of scope for now, but simply testing your business logic whenever there's no web service running is not cumbersome anymore, because you do it simply with one annotation. And you don't need to use any kind of runners, custom runners. It's really a simple out-of-the-box thing. Yeah.
Plus, you can even put it in the method. I mean, creating the server is just like one line.
Yeah, it's one line. Yeah, if you need something more complex, you can do it as well. Yeah, exactly. Yeah. And it also, like, it's the whole thing is fully integrated with Spring. So if you want to have, let's say, like a server, you simply use like a server factory. You specify the responders and you register different responders under context paths, so that all your environments can boot up with one Spring context. And then you can also create like clients and stuff, and they will be simply auto-wired, so that you don't even have to have the the boot up, like the boot up code in your code base. You simply inject it and it works. So that's the thing. That's pretty much it. The roadmap, yeah, it's like the release 1.0 will be really soon, probably like 1 or 2 weeks. So it's not going to be scary to use snapshots anymore, because people are a bit reluctant to snapshots. And yeah, and there's a lot of stuff coming in from the WS specification. So for sure, closer integration with Spring WS, because the biggest disadvantage of SOAP WS now, of the framework now, is that it's like it's using like a web server underneath. So whenever I do SOAP server, I can register many services and stuff using one server. But anyway, I'm booting up like Tomcat or Jetty in the background, and the coolest thing would be that I can simply use it in my JE application and reuse the Tomcat that's running there. So in some cases, in the standalone example, it's cool that I boot up the server because it's easy and I don't have to have any plugins, Tomcat plugins in my Maven and stuff. But in some cases, there's a feature request that for the security department, it's scary that on, let's say, WebSphere, there's another Tomcat like Jetty booting because of some endpoints that you want to expose. So this will be really integrated in Spring WS, so that you can do all the Spring WS thing and simply hook in with SOAP WS in the handling phase. So you don't generate the stubs, but simply use Spring WS with XML directly. And there will be some specifications implemented. It's pretty easy because it's already done in Spring WS, so it's just the reusing of some classes. There will be HTTP binding implemented, which is also not that complex. And from the framework part, for testing, there will be Arquillian. That's like a growing topic now. It's going to be implemented, I hope, so that you can write not only support JUnit or Spock, but also like the container test like with Arquillian. And maybe there will be some, Groovy, Grails, and Griffon plugins. It's like a buzzword a bit because it's simply packaging the application into like a Groovy or like a Grails plugin structure, and it's like more like a Maven dependency, but so that you can install it directly in Grails. But it's nice, and it's also makes the user base bigger. And that's it when it comes to roadmap. There are some success stories, so we've used it in some small projects. We also used it in like a product that we have. Our company is also having a product like for SOA testing, where you can test JMS and web services. And it was really essential then that whenever we, let's say, when you have to expose 10 different versions or even 10 different services, you don't have to generate code for this in the background, because then and load it's not scalable. So everything is done in XML. And there are some guys like in Canada, in the States, using it commercially, and it was tested. They supported it a bit, like sent some patches as well with the biggest bugs, and it's pretty much stable now. So I hope to release the stable version pretty soon. And I don't know if you have some questions, like how many questions did we have? You have a license, you have a license, we still have one license, so if you ask guys one question that I can answer, you can get a license worth $215 US.
Have you thought about migration?
Uh-huh.
Existing projects using SOAP,
Mm-hmm.
maybe a guy can say, I can save a lot of code using this thing. How
Yeah.
can I mix this code
Uh-huh.
into an existing project?
Yeah, I mean, it's pretty easy because yeah, I mean, if you use web services, it's you have the stubs already generated for sure. So the stubs, they are like the you know, like the interface, like the layer that you are using in your business logic. So you can yeah, I mean, it will be a bit of change because this is not providing you with any interfaces. I mean, like, you know, yeah. So you would have to simply change all the places where you use the stubs. Or you can do some kind of like a mediation or proxy first, that you have your interface, you implement it, and the implementation is provided by SOAP-WS. So that, you know, whenever something changes, you simply change this one implementation file, not all of them. But yeah, I mean, changing, I mean, it may be a bit difficult. I mean, it's more if you, it depends how big your use case is, but I would say it's, you have to always think and evaluate if it's really reasonable.
Okay. Until now you used it in brand new projects.
Yeah, in
greenfield
brand new,
projects.
it was easier simply. Yeah, and I also hate the stubs generation. So. Yeah. Okay, any other questions? Free licenses given, so this one is for free, unfortunately.
So just for me that I came in late, what is the model? You're talking about licenses? How does it work? Because you say the project is open source.
No, this one, not this one. I will show you. No, it's our project is open source, but not this one. The company that I work for, they have a product called Retrospective Log Analyzer. It's like for SSH, grepping and tailing, and localhost grepping and tailing, supporting different stuff like column split, line split, like, you know, filters and stuff. It's pretty useful if you have remote servers and you have to connect to them. And they have given me like free licenses for people, you know, asking questions. So I just simply have to note down your. Anybody else ask questions? I don't remember, but yeah, at least you three guys get free license. You can simply then send. You will get the license key next week probably. Yeah, but the project, it's I don't know if we have internet here. Probably not. We have. So, but you don't see this. The project is on GitHub. You can simply play with this, hack around, and there's also like the full project path is like projects revision, and then if you go to SOAP-WS, there's a website with a manual as well. Everything is pretty well documented with examples as well. There's a lot of examples in the example folder, so you can simply like check them out and play a bit. And thanks to CloudBees, like cloud provider, I have a Jenkins where it's built every time when I commit something to GitHub. And the Clover license is also, you know, checking some, you know, like test coverage. So it's around 60% right now, and it's gonna be released soon. So yeah, if you wanna use it, it's also in my there's a refisio.org Maven repository, so you can simply define it as a dependency, and it's described on the website, and yeah, you can right away start using it.
How many maintenance does it?
So the history of it is like it was developed in our company, and I was mainly the developer of this. Now I have some guys who send some patches, but they are not committers yet. They simply send some.
You're the main guy.
Yeah. So I'm basically the main guy. But it's the history is like this. The number of lines that I have really wrote for this project, it's really like, it's not much. It's not many lines. It's like, because I reused like Spring WS, and I reused like, for the message generation, I took the SOAP UI code, because SOAP UI is like, it's open source. It simply has a slightly different license. I don't remember now. But that's the reason that the whole history is described on the website. It's like this, that so the message generation is done by SOAP UI code, and the whole SOAP thing is done by Spring WS. So I simply created some layer on the top to have the client and server, and to have nice builders, and also to integrate the Spring and JUnit things, and yeah, to start the Jetty in the background. But in number of lines, I don't know. I don't know if Clover shows it. Yeah, it's saying now the whole project 10,000, but it's probably less because there's a lot of tests as well. So I would say probably if you divide by 2, it's probably 5,000 lines. So it's really not much. And that was also my goal. Simply reuse as much as possible, not to support code that I write. So yeah, but if you are interested in joining the development and stuff, the roadmap is pretty big, and I'm really open to cooperate with anybody.
Did you use the Jetty client for the SOAP client, or use some?
For
URL?
SOAP client, I use simply HTTP. I don't even use the HTTP client from Commons. I use simply the
URL.
The thing that's in Java. And for server, for server there's Jetty. Yeah, there's Jetty. Really booted like in XML context, like in Spring context. So it's booting up a context, and yeah. Any other questions?
Do you plan to support async IO and like Netty or Jetty 9?
Yeah.
Continuations?
No, they didn't really have it on the roadmap. It's like yeah, maybe, but no. Somewhere, someday. Yeah. If you are willing to contribute the changes, then no. I mean, yeah, it's mostly developed now in my free time. So yeah. Cool. So
Real open source.
Real open source. Yeah. Thanks, guys. Thanks for coming. It was a
Thank you.
pleasure.